Okay, we're going to talk about how to divide polynomials today using long division. First, I think it's worthwhile to just review regular division, long division. I'm going to do 12 into 27. How many times does 12 go into, 277. 12 can't go into 2, so it goes into 27 twice. And I put a 2 up here in that column. The columns are very important with long division. Make sure you match up whichever last number you were dealing with your column. 2 times 12 is 24. I put a 4 here and I subtract and I get a 3. 3 is less than 12 and that's a good thing. So I'll drop down a 7. 12 goes into 37 3 times. 3 times 12 is 36 and I subtract to get 1. Now you know that you can at this point put a 0.0 and drop down a 0 and put a decimal up here and keep going. But what you probably haven't done for a while and forgotten all about is remainders. Back when you're in grade school you would say this is 23 remainder 1. There are 23 groups of 12 that can go into 277, and there's one little thing left over not in a group. And what you might not be aware of is this remainder right here is actually the numerator of your mixed fraction. It's 23 and 1/12. So when you have that remainder 1, you could say 277 divided by 12 is 23 remainder 1. Or 277 divided by 12 is 23 and 1/12. So that remainder actually becomes the numerator of that mixed fraction. Well, over here with polynomials, we're going to do basically the same thing. It's just a little bit more odd feeling at first. I only check, I'm going to take x plus 3 into x squared plus 4x plus 3. This one's going to work out really clean for this first one. I only check the first term. And I just ask myself, how many times can x go into x squared? I'm really saying x times what equals x squared? Well, x times x equals x squared, so I put an x here in this column where I match up the powers. X to the first is matched up with x to the first. Now, just like over here, I did 2 times 12. Here I'm going to do x times x to get x squared, and x times 3 to get 3x. And then I'm going to subtract these, just like how over here we had the subtraction that we did. The subtraction, I think, is the trickiest part. What I like to do is change the signs of everything. If I'm going to subtract this, I'm really subtracting the whole entire thing. So instead of thinking about it as minus x squared plus 3x, I do minus x squared minus 3x. I just switch those signs. When I work this out, I get x squared minus x squared is 0, 4x minus 3x is 1x, then I drop down the plus 3. Now, x goes into x one time. So I do 1 times x is x, 1 times 3 is 3. I'm going to switch these signs because I'm subtracting. And when I'm all said and done, I get 0. This means that this had no remainder. X plus 3 can divide perfectly into x squared plus 4x plus 3 with nothing left over. Really, this means that x plus 3 times x plus 1 would give me x squared plus 4x plus 3. And if you think about division as a process of factoring, it makes perfect sense. X plus 3 is a factor of this, and x plus 1 is a factor of this because there was no remainder. There was nothing left over when we tried to divide them. Okay, we'll do a couple more that get a little bit more complicated, and this will be all. X goes into 2x squared, 2x times, because 2x times x is 2x squared. 2x times what? Sorry. It should be x times what is 2x squared, and the answer is 2x, so I put a 2x up here. So now I multiply everything. 2x times x is 2x squared. 2x times 2 is 4x, and I'm going to subtract these. Subtract this, and that gives me 3x. And I drop down a 7. Now x goes into 3x, I'll switch colors now. X goes into 3x 3 times. 3 times x is 3x. 3 times 2 is 6. And again, I'm subtracting. So when I subtract these, I get a 1. 7 minus 6 is 1. Well, this 1 is now my remainder. Because x can't go into 1 at all, it can go into it a fraction of a time, and that's kind of what we say next. We have this plus 1 over x plus 2. My remainder 1 goes here. Whatever I was dividing by goes here. And I could write this as 2x plus 3 plus 1 over x plus 2. That's the division. Last one, something to be very, very careful of when doing this division. You want everything to have... Oh, wait a second. Is this the last one? This is supposed to be 3x to the third, I think. Either way, I want it to be 3x to the third, so let's just make it 3x to the third. You want to have these in standard form. So I'm going to write this as 3x to the third plus 4x squared plus 0x plus 10. It's very important to have every power represented. So since this only went x to the third, x to the second, and it skipped over an x to the first term, I have a 0x to the first. You want all of those powers on x represented: x to the third, x to the second, x to the first, and this is kind of like x to the 0. We just don't write x to the 0 there. This is going to be divided by x minus 2. Let's start with purple. X goes into 3x to the third, 3x squared times, because 3x squared times x is 3x to the third. 3x squared times negative 2 is negative 6x squared. I subtract these, so that becomes a minus and this becomes a plus. And I get 10x squared. I drop down to 0x. X goes into 10x squared, 10x times. So 10x times x is 10x squared. 10x times negative 2 is negative 20x. I'm subtracting these, so all the signs switch. When I do that, 10x squared minus 10x squared is 0. 0x plus 20x is 20x. So I'm going to get a 20x here. I drop down to 10. X goes into 20x 20 times. 20 times x is 20x. 20 times negative 2 is negative 40. I subtract these, so again the signs switch, and I get a 50. Running out of colors. That is my remainder. Not my answer, my remainder. So the answer is going to be 3x squared plus 10x plus 20 plus 50 over x minus 2. So this times this would get me this. But this means that x minus 2 is not a factor of that expression because I didn't get a whole number. I didn't get a 0 for remainder. Thank you.